Okay, guys, take a look at y equals x squared times e to the 3x. I'm going to read it again. You ready? This is x squared times e to the 3x. If I want to take the derivative of that, how do I do it?
The product rule.
The product rule. Why?
Because they're being multiplied.
Because we have two variable functions being multiplied. So what we're going to do is we're going to come off to the side and we're going to write down our formula, which is first, second, d first, do second. And some of us are continuing to mix up whether we add or subtract in the product and quotient rule, and we just can't have that going into college. So what we do is we do first times the derivative of the
second
plus second times the derivative of the first. So tell me the first function. Tell me the second function. E to the 3x. Tell me the derivative of the first function.
2x.
And then only one of you tell me the derivative of the second. I pick Haley.
3e to the 3x.
Perfect. So it's starting to make sense now?
I guess.
Okay. So we have 3e to the 3x. Does everyone understand where we got those four things from?
Yes.
All right, so put them together with your formula. First times derivative of the second. And if I multiply those two, I would put the 3 first, then if you want to, the x squared, then the e to the 3x. That whole snivert thing, remember that? Yeah? Signs, numbers, variables, radicals, trig functions. So we're going to put our plain, we don't have a negative sign, so we're going to put our plain number first, then our variables, and then our radicals and trig functions, or any other functions we have. So that's why I'm going to write it 3x squared e to the 3x. So first times derivative of the second plus
2x.
second times derivative of the first, which is 2x, e to the 3x. All right, now what, you guys? Can we stop there?
No.
Would you factor out?
Would you combine like terms?
Yes, it depends on the directions. If they say factor, factor. Typically with derivatives, we do factor. So we could take out a, and we're multiplied by
So 3x plus 2.
plus 2. Perfect. Now there's nothing wrong with this one. Just pay attention. Sometimes with derivatives, we do say go ahead and factor. Okay, so that's one where you have to involve the product rule. Let's see what's next. If we want to find the relative extrema of f of x equals x e to the x, the first thing we have to do is find the derivative, and that requires us to do the product rule. So we have to do first and the second, the derivative of the first, which is just what?
1.
And the derivative of the second,
Yes.
which is its own derivative. It's weird. It's kind of like being your own grandpa, right? I'm not very comfortable with it. Okay, so our derivative is first times derivative of the second plus second times derivative of the first.
It's a good song.
You like that one?
I love that song.
So we have x e to the x plus 1 e to the x.
Yeah.
Okay, so there's our derivative, and we can factor a what out?
Yes.
E to the x multiplied by x plus 1.
Oh.
So there's our derivative, our factored derivative. And we do want it factored because we're going to set it equal to 0 and solve each factor equal to 0. So if I set that equal to 0 to find my critical numbers, I have e to the x equals 0, and I have x plus 1 equals 0. If I take the natural log of this guy, right here, that's how you solve an exponential equation, which is why we reviewed it in the beginning. And we just get x equals natural log of 0. Natural log of 0 is
It's like an error.
it 1 or is it undefined?
Undefined.
Or is it undefined? You can't take the natural log of 0. Now the natural log of 1 would be 0. But the natural log of 0 does not exist. It's undefined. So we don't get any critical numbers from this one, but we do get one from here. What do we get? That's going to be our only critical number. And we're going to use that on our number line to test for increasing and decreasing. So we put a -1 here. We will test a negative, you guys want to test -2 and 0 into our derivative. So if I put -2 into the derivative, you guys check it out for me. I take -2 and I put it into this derivative right here. Does it give me a positive or negative? I think it's a negative, right? Okay, so it's decreasing from negative infinity to negative 1. And if I put 0 in, I get a positive. A positive 1? Okay, so it's increasing from negative 1 to infinity. So the only relative extrema I have occurs here, if it's defined. And so that would be a relative minimum, because it goes from decreasing to increasing. And that would occur at negative 1, comma. How do I find that y value?
Into the original.
Original. So if I put a negative 1 in here, I get negative 1e to the negative 1. So let's just say negative e to the negative 1. Or you could give it to me as a decimal if it didn't say exact. And somebody said that was negative 368-ish. All right. So that kind of helps you have a better understanding of it. And we have no relative maximums because it never goes from increasing to decreasing. So for this one, we want to find the equation of the tangent line to the graph of g of x equals x e to the 2x at the point 1 comma e squared. So the first thing we do is we take the derivative, and we use the product rule to do that. So we have first times the derivative of the second, which is 2x e to the 2x, correct? Yeah. Plus the second times the derivative of the first, which is just e to the 2x. Now normally we would factor that out, the e to the 2x, so there's really no need in doing that, because why? We're just looking for the slope, right? So we don't really have to factor unless you just want to. So if you want to, you can. Either way, it doesn't matter. You have to if you're looking for critical numbers, but if you're just looking for the slope, you can just plug in.
That makes it a little easier when you factor it when you plug it in.
Oh, really? It's easier to plug in? Okay. So let's factor it and plug in 1, and we get 3. So we have e to the 2 times 1, right, you guys?
Yeah.
Yes, e to the 2 times 1 multiplied by 2 times 1 plus 1, which is what, 3? So is the slope 3e to the second? Is that what everybody got? 3e squared? Okay, so that's our slope, 3e squared. And then to find the tangent line, all we do is use our point slope formula. Y minus y1 equals in parentheses x minus x1, close the parentheses.
Miss Hughes,
Yes, sir?
how did you go from the 2x e2x plus e2x to the e2x?
I factored GCF, I took the e to the 2x out.
Okay.
Yeah. And then I just plugged in the 1 and got 3e squared. So we have y minus e squared equals m x minus 1. So it looks like y minus e squared equals 3e squared times x, or xe squared, really doesn't matter, minus 3e squared. And if we add e squared to both sides, what do we get?
3 squared x minus.
All these e's are kind of weird looking. 3e squared to the x minus what?
2e squared.
2e squared. That's perfect. And that's the equation of your tangent line. And that's pretty much all you need to know for differentiating exponential functions.